Hello friends, welcome back. In earlier few videos we have seen the IUPAC nomenclature system for naming the coordination compounds. Now in this video we are going to study the stereochemistry of the coordination compounds. So let's start with this. So stereochemistry, or we can say the different geometries of the coordination compounds, and here we have to study with the coordination number 4 to 10. But generally the coordination numbers, they are ranging from 1 to 12. So the coordination number of the metal ion, it is having 1, which is occurring in the ion pairs. Ion pairs means such as Na plus Cl minus, and it occurs in the vapor phase. Coordination number means how many ligands they are attached or they are surrounded to the central metal atom or the ions. So the coordination number, it ranges from 1 to 12, and this 12 coordination numbers, it occurs in some mixed metal oxides, right? Now out of these coordination numbers, we can say that the most common coordination numbers, they are 4 and the 6. The coordination number 4 and the coordination number 6, these two coordination numbers, they are the most common coordination numbers, whereas the coordination number 2 and 3, they are not very common. So let's study each coordination number one by one. Now in here we have seen the coordination number 1, which occurs in the ion pair such as Na plus Cl minus, right? Let's move on. We are having the second, that is a coordination number 2. What is the coordination number 2? Which it is having one metal which is surrounded by two ligands. So depending upon this, we are having two geometries are possible. The first geometry is the linear geometry. Linear geometry, that means in one straight line fashion. In one straight line fashion, at the center we are having the metal and it is attached to two ligands. So this linear geometry is like this. We are having at the center a metal and it is attached to the two ligands. So it is a linear ML2. Its example is AgNH3 twice plus. That means this metal silver is at the center and it is attached to two NH3, which is in a linear fashion. So its structure is, or its geometry is like this. We are having the silver at the center and it is attached to two ligands, which is the NH3 ligands, and it is in a linear fashion. One more example is the AuCl2 minus. Also we are having the HgCN2 minus. So these are the examples of the linear with the coordination number 2. Now second geometry possible for the coordination number 2 is the bent geometry. Bent geometry means at the center we are having the metal, and this metal, they are attached to two ligands in a bent fashion. But the examples of this geometry are not very common, or we can say they are uncommon. And the geometry is like this. At the center we are having the metal and in a bent fashion it is attached to two ligands. Okay, so this is regarding the coordination number 2. Then we are having the coordination number 3. Coordination number 3 means we are having the metal at the center and it is surrounded by the 3 ligands. So for this, we can say this coordination number is again not very common. Two geometries are possible. The first geometry is the trigonal planar. Planar means all the 3 ligands, they are in the one plane, or we can say the metal as well as the 3 ligands, they are forming the one plane. So this is a trigonal planar. At the center we are having the metal and it is attached to 3 ligands, and all the 4, they are in a one plane. Therefore it is called as the trigonal planar. Its example is the Hgi3 minus. That means we are having at the center a silver Hg mercury and it is attached to 3 iodide ions, right? And all the 4, they are in a one plane, and therefore it is called as the trigonal planar. The second geometry for the coordination number 3 is the trigonal pyramidal. That means the 3 ligands, they are arranged in a pyramidal fashion like this. It is called as a trigonal pyramidal. And its example is H3O plus, which is known as the hydronium ion. So the hydronium ion is like this. At the center we are having the oxygen and which is attached to 3 hydrogens with the plus charge. So this is trigonal pyramidal. Then next, that is the coordination number 4. Now we have seen that this is the most common coordination number. Two geometries are possible. The first geometry is the tetrahedral geometry and the second geometry is the square planar geometry. So let's take the first one, that is the tetrahedral geometry. Now coordination number 4 means we are having a metal at the center and it is surrounded by 4 ligands. Now in the tetrahedral geometry, the 4 ligands, they are surrounded to the metal tetrahedrally. Okay, so we are having the metal at the center and it is attached to 4 ligands in a tetrahedral fashion. This is the tetrahedral arrangement with planes. Okay, at the center metal, this is the first ligand, second ligand, third ligand and the fourth ligand. They are arranged tetrahedrally. Their examples are ZnNH3 4 2+. So it is the structure. At the center we are having the metal Zn 2+ and it is attached to 4 ligands and they are in a tetrahedral fashion. Similarly, one more example, that is a CuCl4 2-. Again here we are having the Cu, that is the central metal, which is surrounded by the 4 ligands with the tetrahedral fashion, right? So this is the tetrahedral geometry for the coordination number 4. Now let's see the second geometry, that is the square planar geometry. Planar means all they are in a one plane, they are forming one plane. So this is the square planar geometry. We are having metal at the center and it is surrounded by the 4 ligands and all the 5 atoms, they are in a one plane. So this is the geometry with plane. That means all they are in a one plane, right? So its examples. The first one is the PtNH3 4 2+. And its structure is like this. We are having at the center a metal platinum 2+ and it is surrounded by the 4 ammonia ligands and all the 5, they are in a one plane. Second example is CuNH3 4 2+. Again, at the center we are having the copper 2+ and it is surrounded by the 4 ligands and all they are in a one plane. So this is regarding the second geometry, that is a square planar geometry for the coordination number 4. Then next coordination number is the coordination number 5. 5 means the central metal atom or the ion is surrounded by the 5 ligands. Now for this, two geometries are possible. The first one is the trigonal bipyramidal, which is called as the TBP, and the second geometry is known as the square pyramidal or SP. These are the short forms. First one is the trigonal bipyramidal, second is the square pyramidal. So let's start with the first one, that is the trigonal bipyramidal. Now as the name suggests, trigonal. Now out of the 5 ligands, the 3 ligands, they are in a trigonal fashion. And the bipyramidal means the remaining 2 ligands. Out of the 2 ligands, one will be above the triangle and the second will be the below the triangle. So this is a trigonal bipyramidal structure. These 3 ligands, they are in forming the triangle or they are called as a trigonal. And then one is above and the second is below. This is called as a trigonal bipyramidal. So this is the arrangement of the 5 ligands with planes. So here we can say that these 3 ligands, they are in one plane, then the above and then the below. So this is called as the TBP, or we can say the trigonal bipyramidal. Its example is FeCO5, iron pentacarbonyl. So the iron pentacarbonyl is this one, FeCO5. Again, the metal is at the center, it is surrounded by CO, CO, CO. These 3 carbonyls, they are in one plane or trigonal fashion, and then one carbonyl is above and the second one is the below. Okay. Then second example is the MnCO5-, then CuCl5 3-. Now here we can say that out of these two geometry, TBP and the SP, this trigonal bipyramidal geometry is more stable than the square pyramidal geometry, because here all the 5 ligands, they are symmetrically arranged around the central metal atom. So the second geometry is the square pyramidal or the SP geometry. Now as the name suggests, we are having the geometry, the 4 ligands, they are in a square fashion and then the remaining 1 ligand is above oriented. So it is called as the square pyramidal. So we are having the geometry with the planes. So all the 4 ligands, they are in one plane and the remaining ligand is in another plane. Example is IF5 and its structure is like this, I and F5. So these 4 ligands, these 4F, they are in one plane, whereas the remaining F is the above oriented. So this is the coordination number 5, which is less stable as compared to the earlier, that is the trigonal bipyramidal. Next example is the NiBrC2H5 thrice P 2 times ACAC 2 times. Then let's move on. The next coordination number, that is the coordination number 6. Again, this coordination number is a more stable. We have seen the coordination number 4 as well as the coordination number 6. Both these two coordination numbers are the more common coordination numbers. Now 6 coordination number means the central metal is surrounded by the 6 ligands, right? So majority of the coordination compounds are 6 coordinate. Again, 2 geometries are possible. The first geometry is the octahedral geometry. Octahedral geometry means at the center we are having the metal and the remaining 6 ligands, they are arranged octahedrally like this. That means at the center metal it is surrounded by 4 ligand in one plane, then the remaining 1 ligand is above oriented and the second ligand is below oriented. So this is called as the octahedral arrangement, and the second arrangement is the trigonal prismatic. So trigonal prismatic, this is the second arrangement. Now out of these two arrangement, octahedral arrangement is more stable, or we can say that the coordination number are always found in one regular geometry, that is the octahedral geometry. Octahedral geometry, this is the octahedral geometry because this is the most symmetric arrangement of 6 ligands around the metal ion. Okay, we can see that in this octahedral geometry all the 6 ligands, they are arranged symmetrically. Therefore this is the most stable. Its example is ZnNH3 2+. It is like this. So here we can say that at the center we may have the Zn, or here instead of this cobalt we are having the Zn and it is attached to the 6 ammonia ligands, right? Now here we can say that at the center we are having the metal and it is attached to the 6 ligands octahedrally. Now here, as we have seen that all the 6 ligands are symmetrically arranged, but some distortions in the structures can produce other modified arrangements, and due to this modification there may be elongation along the z-axis which is producing a tetragonal structure, or there may be a compression of the z-axis which is called as the trigonal structure. So let's see this tetragonal and the trigonal structure. So we are having, this is the normal octahedral arrangement. In a normal octahedral arrangement we are having at the center metal and it is surrounded by the 6 ligands octahedrally. That means all the lines, or we can say that they are at the same positions. The positions or the distance of all the ligands from the metals are same, but when there are some distortions, suppose this is our z-axis. Along this z-axis either there is elongation or there is a compression. So the first one is the elongation along the z-axis. So along this z-axis there is a elongation, and due to the elongation we are getting this structure. So this is the elongation along the z-axis, right? Due to the elongation the bond length or the ml bond length increases, which is along the z-axis, and due to which we are producing the structure which is called as a tetragonal structure. On the other hand, when there is a compression of z-axis, so along this z-axis when there is a compression or shortening, and due to the shortening we can say we are getting this structure due to the bond length of this M and L. ml bond length decreases. Here there is a shortening along the z-axis, or we can say the compression, and due to which we are producing the structure which is called as the trigonal structure. So this is regarding the coordination numbers from 1 to 6. In the next video, we are going to study the remaining coordination number, that is from the coordination number 7 to coordination number 12. Thank you.